Welcome to the Explainer. Today, we are looking at our world in a brand new way. We are moving from fixed, rigid rules to flexible connections. It changes absolutely everything. You see this shift in science, you see it in nature, and you even see it in business. Let's dive right in. Here is our map for today. First, we will cover no more fixed rules. Next, we will see how ancient ideas meet science. Then, we will be careful with comparisons. After that, we look at why rigid systems can fail. Finally, we will explore flexible ways to survive. Section 1. No more fixed rules. For a very long time, we thought the universe was just a giant, predictable machine. We thought time ticked at the same speed for everyone. We thought solid objects never changed. But modern physics completely destroyed that old view. The theory of relativity showed us that time is actually not absolute. It changes depending on who is watching. Then, quantum mechanics showed that even a particle's position is not fixed. It's just a probability. Reality is simply not a fixed, solid stage. Let's look a little closer at quantum mechanics. What exactly is it? Well, it's the branch of physics that studies incredibly tiny particles. And the main takeaway is fascinating. These tiny particles don't actually have a fixed solid form. They exist as a wave of possibilities. They only take a solid form when they interact with something else, like a measurement tool. In short, reality depends on relationships. Section 2. Ancient ideas meet science. These modern scientific rules probably sound totally new and a little strange. But here is a surprising fact. These concepts are actually ancient. The famous scientists who built quantum mechanics, like Werner Heisenberg and Erwin Schrödinger, were fascinated by Eastern philosophy. They read ancient Asian texts, and they realized that thinkers from thousands of years ago were asking the exact same deep questions about reality. You can actually compare these two worlds side by side. Modern physics tells us that objects lack fixed states. Reality is based entirely on relationships. Now, look at Buddhist philosophy. It teaches that things lack a fixed essence. It says everything in the universe is deeply connected. Both of these very different fields agree on one massive idea. Nothing has a fixed, independent reality. Section 3. Careful with comparisons. It is incredibly easy to get excited about these parallels, but we need to pause for a quick reality check. We have to separate the true matches from the false ones. Yes, both fields question a fixed reality, and yes, both deeply value connections. But quantum math does not equal Buddhist ideas. Mathematics is a tool for physics. Philosophy is a guide for human life. They are very different tools, and they don't share the exact same truth. There is one really important warning here. You will often hear people say, human consciousness creates reality. Well, that is a huge mistake. In physics, the word measurement doesn't mean a human mind is performing magic. It simply means a physical interaction takes place. A machine measuring a tiny particle is just a physical event. So it is crucial that we don't mix up human minds with quantum physics. Section 4. Rigid systems can fail. We just talked about abstract science and philosophy. Now let's step into the real world. Real-world events clearly show why rigid systems are actually quite dangerous. Take the business world, for example. Think about how cars are built. A single car has thousands of parts. Car factories wanted perfect efficiency, so they used highly rigid supply chains with very few extra parts. But when a massive earthquake and tsunami hit Japan, this rigid system completely broke. Production just stopped. A flexible system with many adaptable sources survives disasters much, much better. We see this exact same danger with nature defenses. Many coastal towns built giant concrete seawalls. People truly believed these massive, fixed walls would keep them completely safe. But during the huge tsunami, those rigid walls failed. The ocean waves were just too powerful. They easily smashed right through the hard concrete. It proves that a fixed, hard rule is not always enough to protect us. Section 5. Flexible ways to survive. When rigid things break that easily, we clearly need a new approach. Flexible, adaptable rules actually save lives. Let's look at a smart, historical example. It is called the Tsunami Tendenko rule from the Japanese coast. It has 3 simple steps. Step 1, do not wait for others. Step 2, run to high ground individually. Step 3, trust that your family is also running. This is a brilliant, flexible rule. You don't wait around for central orders. You act quickly on your own. Because everyone acts flexibly, many more lives are saved. Here is another beautiful example of flexible thinking.
In a Japanese village called Anayoshi, there is an ancient stone monument. The carving on the stone simply says, "Do not build homes below here." The people there didn't try to build a rigid wall to fight the ocean. Instead, they adapted to nature. They built their homes higher up the hill. They chose to live safely and flexibly with their environment.
We have reached the end of our explainer. We started out looking at tiny quantum particles. We ended up looking at giant ocean waves. But the core lesson is exactly the same. Fixed rules and rigid walls often fail under pressure. It's the flexible connections that help us survive. So, I will leave you with this final thought. When the next big challenge hits your life, will you break like a rigid wall, or will you bend, adapt, and survive? Thanks for joining us today.